We're doing question 3 and it's asking us at a snapshot of t equals 0 of this particular wave here moving to the right at 1.5 meters per second, what it would look like after 4 seconds. We concluded that after 4 seconds, the wave would have moved 6 meters and the wave would reflect back in an inverse way. And as you can see the dotted lines here, this is the wave that is being reflected back. And with superposition, we take the negative side of the wave and we cancel it with the top. And then all the waves that intersect would actually add to the existing wave. And after we added it together, this is what the wave would look like after 4 seconds.
Hi, this is the second section of question A. So this one is the original graph in the question when t equals to 0 in here. And the question is when t equal to 4, what's the snapshot graph and the n is free. So for this graph, we draw when t equals to 4. Because the velocity is 1.5, so it travels 6 meters. So we just simply transfer this graph to the right for 6 meters, and then this is the graph showing. And since the n is free, the pulse bounce back is not inverted. So it just shows the exactly graph of this part, but in the inverse way, inverse direction. And then we draw the graph that combines together, like the areas that combines together. So the final snapshot graph is there.
In questions B, we have this snapshot, and it's asking for a histogram at x equals to 4 meters. And we have the wave, snapshots of the wave here. And we know the velocity is 0.5 meters per second. We get a total time of traveling, 8 seconds here. And it's asking a histogram at x equals to 4. And I assume I'm standing here and feel the wave, and in 4 seconds, and let me show you, 1 second is 0.5 meters, which means 0.5 meters here, and it's 1 second. And the first second is flat here, and then it's going down. You can feel the wave, it's going down on the side. So I got it going down at 4 seconds here, and it's minus 3 positions here, and it's going up, going down and flat. And basically it's just like a wave upside down, where you flip it over here, and that would be the histogram at x equals to 4.
So for the last part of the question, we're given the original graph saying that we're moving velocity is 2 meters per second. So we know the first graph, the total wavelength is 4 meters, so that would take us 8 seconds. So we kind of broke up the grid into second segments to help us visualize it easier. So for the first meter, the wave does not move, so it's stagnant here until a half a second, and then it goes up just like this, and down all the way to -3, and then back up to no displacement at 3.5 or 1.75 meters.